Okay, Assalamualaikum and good afternoon. Um, let's start the class lah because already 40%, so more than half of our class. So how are you? Hopefully you are fine. Okay, so and also if you are not taking exam for this Monday, okay, if you are from red zone, okay, please notify me lah so that I know lah. Okay, one person already informed me last night that she will not going to join us for final exam this Monday. Okay, if the rest of you from the red zone, you can inform me lah so that I know. Okay, but so far we don't we still wait for the instruction from the top management lah what to do. Okay, but I think it will be just special exam for those who cannot join this phase 2. Okay, today I just want to discuss about the final exam. So as you know, it will be on this Monday, 5 October, okay, 2020. Hopefully you are ready, okay, because you have a quite a long time for the study weekend after we finish the class, okay. Saya pun dah tak ingat dah bila kita finish the class, okay. It's too long already, okay. Okay, so can you hear me? Boleh nampak my screen?
Ya, boleh.
Okay. Okay, so I ask you to do this version, the latest one, which is last semester 1, 2019-2020. Okay, and we already upload the answer scheme. Okay, so you can do and you can compare lah the answer with your answer. Okay, so the general idea about the final exam, the number of question will be similar as the previous one. Okay, so I think here we have about 7 questions, so it will be 7 questions on this Monday. Okay, and pattern will be similar. Okay, so pattern means that how we arrange the question will be similar. Okay, it will be from chapter 2 and onward. Okay, chapter 1 it will be it's not yeah, it can be it will be everywhere because it is a theory. Okay, a theory that you have to know, but it will be no more like box plot and so on. Okay, no more calculation from chapter 1, but it will be like theory that you have to know. For example, level of measurement, type of data, qualitative, quantitative, something like that. Okay, basically you have to know the theory. Okay, so the chapter 2 and chapter 3 it will be combined. Okay, sometimes it will be combined in one question. You have to do the hypothesis testing and also you have to do the confidence interval. Okay, and the rest will be chapter 4, 5 and 6. Okay, if you notice, it will be quite similar as this one. Okay, our final in this Monday will be, the pattern will be similar with this one. Okay, if you notice, for the chapter 2 and 3, you have about 29 marks. Okay, and chapter 4 until 6, you have about 71 marks. Okay, so from here, we can say that if you want to score the final, better to focus chapter 4, 5 and 6. Okay, chapter 4, 5 and 6. Chapter 2 and 3, as you know, it will be quite complicated questions. Okay, so you can focus more on the chapter 4, 5, 6. It is quite straightforward question. In terms of the formula, we don't have to choose a formula. Okay, it will be single formula for each subtopic. Okay, no need to choose the formula. Okay, for the chapter 4, 5 and 6, okay, you have single formula. Then it should be easy lah. Okay, chapter 4, 5 and 6. But you have to know the concept lah. Okay, for example, chapter 4, how to calculate the one-way ANOVA, and also how to read the one-way ANOVA based on the output given. Okay, chapter 5, it will be like interpretation. Okay, most of the value that we calculate, we have to interpret. And chapter 6 quite straightforward lah. Chapter 6 quite straightforward. Okay, you have two subtopic from chapter 6. Okay, the first one, goodness of fate task, and the second one is contingency table. Okay, so if you go through the series of the final exam, okay, then you know lah. Okay, from chapter 6 it will be two questions, one from the first subtopic, goodness of fate, and the second one from the contingency table. The pattern will be similar. Okay, and you will have two questions from two or one question, I think two questions from chapter 4 and two questions from chapter 5. Okay, so chapter 4 it will be two questions from chapter 4, and chapter 5 it will be simple linear regression and also multiple linear regression question. Okay, the pattern will be similar as a previous final exam. Okay, you can see lah that one. Okay, the difference is the question it is lah. Okay, so any questions so far, you can interrupt me. Okay, if you have any question, you can ask me directly, no need to wait. Okay, so we go to the this final exam. Okay. Okay, for the first question, we are not going to, I am not going to discuss in detail the answer because you already have the answer scheme from the column. Okay, so but you have to know the keyword here lah. Okay, so why it is a proportion, you have to know why it is a proportion, because we have percentage of something. That's why we have proportion. That's why it is a proportion. Okay, you have percentage or probability of something, it will be proportion case lah. Okay, and also another keyword for the proportion, if you have qualitative data. Okay, so the number of the bottle here, it is a frequency. Okay, we calculate the frequency of the data. Okay, but originally when we collect the data, it is a qualitative data. Okay, for example, first bottle, full or not full, that the data that we collect, whether it is a full or whether it is a not full bottle. Okay, so you have qualitative data. So when it is a qualitative data, automatically parameter that we are going to use is a proportion lah. Okay, that one a basic thing that you have to know lah. Okay, we have discussed this in class, if you still remember, when we discussed chapter 2 lah. Okay, because we still I'm not I think kita sempat juga kan, tak lupa dah. Okay lah. Okay, okay, so the reason why it is a proportion, because we have percentage of the something here. Okay, so the variable, it could be number of bottles that full or number of bottle which is not full. Similar, both will be accepted lah. Okay, so the conduct atas, so automatically it is a hypothesis testing. When we say conduct atas, it is a hypothesis testing. Or let's say that you have question like, can you conclude that? Okay, can you conclude that if the machine is operating properly? Okay, also hypothesis testing. Okay, when we say, can you conclude that? You have to conclude something. So the conclusion coming from the hypothesis testing, not from the confidence interval. So obviously it will be hypothesis testing lah. Okay. Okay, but I believe that if you consistently do the tutorial questions and also the exercise question and also a series of final exam, you will be well known with the questions. Okay, you will be well known with the questions. When question asks you like this, then what to do? Okay, you should be well known with the questions. Okay. Okay, so this is a single proportion. The B question, you have two proportion, which is product A and product B. So the first question here, okay, do the data provide sufficient evidence? So you have to make your conclusion here. So automatically hypothesis, conduct a appropriate task by applying the confidence interval approach. Okay, so we have confidence interval approach. So means that you have to conduct the hypothesis here by using confidence interval approach. Okay, so you have three approach. Okay, you have three methods for the hypothesis testing. Okay, the first one, traditional method. Okay, traditional method means that you will use statistical task to test that. You have Z, you have T, you have chi-square, and also you have the F-test. Okay, those are traditional method. Okay, jangan bertukar The second method that we have is a confidence interval method. Okay, so what is the difference? The difference is you don't calculate the test statistic. You calculate the confidence interval and then we compare with the alpha. With the what we call hypothesized value or the population value. If you are talking about the mu, then we compare the confidence interval with the mu naught. If you talk about what sigma, so we compare with the sigma naught. Okay, traditional method, we compare the test statistic with the critical value that you get from statistical table. Okay, confidence interval, you calculate the confidence interval and then we compare the hypothesized value, or you call it as a population value, or we call it as a true value lah. Okay, pendek cerita, your mu naught, your pi naught, your sigma naught, and also okay, that's it lah. Okay, and also bear in mind the confidence interval approach only for the case two-tail. Okay, even though you calculate for the one-sided confidence interval, still we have to write two-sided interval. So it is not available for the one-tail case, right tail or left tail. Okay, so I hope that you do understand what I'm talking about. The terms, all the terms should be well known right now. Okay, we are close to the final exam. So confidence interval only for the two-tail case. In the case that you have equal and not equal for your hypothesis testing. Okay, and the third methods or approach that you have is a p-value approach. Okay, for the case p-value, if the question need you to use a p-value, the p-value will be given in the question. Okay, so how it will be given? Through the output from Microsoft Excel. So we will provide you with the output from Microsoft Excel if you need to do the p-value approach. Okay, so you don't calculate manually the p-value. Okay, even though in your module, you do have how to calculate manually, but we don't apply that. Okay, we give you output and then you read the p-value from that output. So here, you have to know how to read the output. Okay, so you can go through your module. Okay, how to read the output. Which one is a p-value? Okay, because sometimes some of the output, if you still remember, you should know actually. Okay, for example, output for the case mean, population mean. Okay, you will have two value for the p-value, one for the one tail and another one for the two tail. So you have to know, you nak pakai yang mana. Okay, you nak pakai p-value for the one tail or you nak pakai p-value for the case two tail. So all depends on that, all depends on your hypothesis. Okay, whether you have two tail, whether you have one tail. Okay. Okay, So obviously here you have to use a confident interval approach. Okay, so based on this hypothesis kat sini mesti dapat two-tail. When you formulate your hypothesis here, it must be two-tail case. Kalau you dapat one tail, something wrong lah, because in order to use a confident interval approach, it must be the two-tail case. Okay. Okay, so the step you can go through the module, okay, and you can look at the answer scheme lah. Okay, and this is just a simple question. Identify the type of hypothesis. So obviously it will be two-tail lah because of we are using confident interval approach. Okay, so here actually the example of we combine chapter 2 and also chapter 3. Okay, when we need to calculate for the confident interval, it will be something from the chapter 2 and apply in chapter 3 here. So one of the example, how do we combine chapter 2 and 3? Okay, by using similar scenario. Okay. Okay, ada soalan ke tak ni? Oh, tak ada soalan. Okay. Okay, you can interrupt me if you want to ask any question. No need to wait. Okay. Okay, we move to the question 2. I do hope that you already do so that you know lah what we are discussing now. Okay. So question 2 here, verbality. So the first question here is, no, the first word here, that's your keyword lah. Keyword for the parameter used in this question. So verbality means that it is sigma. Okay. So you have band X, band Y. So it is a ratio of two population variance. Okay, you are given Microsoft Excel output. Okay, when we provide you with the output, it will be exactly similar as in Microsoft Excel, including this title. So from this title, you should know we are dealing with which parameter. Okay, another keyword that can, another hint or keyword that you can use lah. Okay, based on the title of this output. F-test to sample for the variance. So janganlah pula hypothesis pergi tulis pi, pergi tulis mu. Okay, very totally contradict lah. Okay. So it is clear here, we are using variance to sample. So ratio of two population variance confirm. Okay, your hypothesis must be sigma 1 and sigma 2. Okay, must be sigma. If you want to use the alphabet here, so sigma x and also sigma y. I don't want to see the mu, I don't want to see the pi. Okay, it is clear here we are dealing with the sigma. Okay, so you can use the title of this output if you have the output to decide what parameter that we have. Okay, so another reason why you have to try the series of the final exam and also the tutorial question. Okay, not only okay, exercise also you can do, but you cannot depend too much on the exercise because okay, exercise we do divide by topic. Okay, we arrange the exercise by topic. So you already know if you do the exercise under population mean, your parameter will be mean lah. Okay, but when we go to the tutorial question and also final exam, we do mix those questions. So you have to decide your own parameter based on the question. So another reason why you have to do the tutorial and also final exam question, so that you will have experience how to decide on the parameter. Okay, because if you have qualitative, then it will be proportional. But if you have quantitative variable, it will be either two, whether mean or whether variance. Okay, so it is important lah. Okay, how to decide on the parameter. Okay, so identify the parameter involved. Kalau tak boleh jawab yang ni memang saja je ni. Okay, should be variance. So using 7% significant level, do the data support the claim that band X provide more efficient service time than band Y? So use the p-value approach. Okay, so here definitely you have to use the p-value. Okay, you tak boleh pakai traditional or confident interval, memang totally zero here, or you just get the mark for the hypothesis lah. Okay, because you didn't follow the question. Okay, so p-value. Okay, so p-value band X provide more efficient service time. So formulate your hypothesis and then use a p-value approach. So p-value we compare with the alpha. Okay. Okay, band X provide more efficient service time. So you have to decide the sign here based on probability because we talk about probability. So in terms of the probability, band X provide more efficient service time. It should be sigma X less than sigma Y lah because variable must be smaller in order to have a good service time. Okay. Okay, so then we use a p-value approach. Okay, another thing, when I mark your assignment last time, I do notice some of the problem when you use a p-value approach. Okay, when we use the p-value approach, we will compare with the alpha. Okay, doesn't matter your hypothesis is a two-tail. Okay, even though your hypothesis is a two-tail case, we don't divide alpha by 2 for the p-value approach. Okay, we just compare with as it is alpha. If 5%, then compare with the 5%. Even though you have two-tail case, we don't divide by 2 the alpha. But if we use a traditional approach, if you have two-tail case, then we divide alpha by 2. Okay. And you should know lah, if the alpha is not given, it is 5%. Okay. Okay, so number 3 here, so which one, okay. So number 3 here, based on the decision that you do here, so it is a sigma X less than sigma Y, H1. H0 sigma X greater and equal to the sigma Y. So kalau you reject H0, we accept H1 means that X more efficient. So kat sini jawapan dia Y lah, less efficient. Kalau you accept H0, do not reject H0, Y is more efficient. So kat sini X lah less efficient. So based on your decision. Okay, the type of error here. Okay, so the type of error here, it is depends on your decision also. Okay, I discuss sikit the type of error ni because the question quite famous the type of error. Kita selalu juga tanya dalam final the type of error. Okay. Okay, in general, you have 2 error. Okay, for the hypothesis testing. The first one, type 1 error. Okay, I hope that you know what I'm talking about. The second one, type 2 error. Okay, in general. But you can write another error which is no error. No error or it is a correct decision. Okay, so it will be 3 type of answer that you can write in that question lah. Okay. So first, to decide the error, you have to know H0 is true or false. Okay. To decide whether H0 is true or false, it is depends on your claim. You claim dekat mana? Okay. Kalau you punya claim dekat H0, maksudnya H0 is true. Okay. Kalau you punya claim dekat H1, H0 is false. H0 tu salah. Okay. So type 1 error, it is a reject H0. Probability of the reject H0 if H0 is true. Okay, so you sekarang ni untuk type 1 error maksudnya you punya claim dekat hash null. So kita dah decide hash null is true. Tapi decision nanti you reject hash null. So you akan ada reject hash null, why hash null is true. So it is type 1 error. Okay. Okay, type 2 error, the probability of do not reject hash null. Why hash null is false. Okay. So kenapa hash null tu false? Sebab you punya claim dekat hash 1. So claim dekat hash 1 means that hash null is false. Okay, and then decision letter, it is do not reject. Kita tak reject hash null sedangkan hash null tu false, salah. So it is type 2 error. That's how we decide. So the error in this question, okay, the error in this question, it is an open question, but it is depends on the answer from 2 and also from the answer from 2. Okay, kita akan tengok dekat sini, you decide which one is a claim and also what is your decision. Okay, you punya answer kat sini, it could be different from the answer scheme. Okay, kalau kat sini salah, kat sini mungkin different, akan salah jugalah. Tapi salah dari segi answer scheme. Tapi kalau you buat dengan betul based on apa you buat kat sini, you still got full mark lah. Okay. Okay, another one is a no error. Tak ada error ataupun correct decision. Correct decision? Decision yang betul lah. Okay. So no error ni berlaku bila you ada reject hash null, why hash null is false. Hash null tu salah, tak betul, and then we reject. So it is correct decision to do lah. No error. And another situation when you do not reject hash null, why hash null is true. Hash null tu betul and then kita tak reject, kita accept that hash null, then you are making correct decision or no error. Okay, so ada 3 jawapan you boleh tulis on that question. The first one type 1 error or type 2 error or no error at all. No error or correct decision. Any questions so far? Tak salah? Are you listening to me kan? Ataupun you buka je pergi mana? Tak salah?
Ada.
Ada je, ada kat sini je.
Okay. Okay, so we proceed. Okay, done with the question 2. Okay, question 3, it is about one-way Anova. Okay, so one-way Anova here. Okay. So the first one, why it is a one-way Anova? Because you have 4 different type of solar energy. Okay, you have more than 2 population. Okay, so when we have more than 2 population, then we are comparing the mean here, then it is a one-way Anova lah. Okay, can you conclude that the mean power differ for the different type of panel? So keyword here, mean, population mean, and also you have 4 panels. If you have single panel or 2 panel, then we cannot use a one-way Anova lah. Okay, so one-way Anova for the case of more than 2, 3 and above, and also we compare the mean. And you should know lah, this is a one-way table, one-way Anova table. Okay, so what we give you here is a table from Microsoft Excel. Okay, and there is no data given. So bila you ada table macam ni, you kena tahulah how to play around with this value. Okay, to get this value and the incomplete value here, you can use the value that we have here lah. Okay, but the degree of freedom here, you have to know lah how to find all those. You have to, the degree of freedom here, most of the time you have to know how to, you have to know the formula. Okay, okay, so like So how many treatment involved? Treatment is a population number. Okay, how many population that you have? So here we have 4 treatment lah. Okay, 4 panel, so 4. So treatment equal to 4 or K equal to 4. Okay, small k. Copy and complete the Microsoft Excel. So you have to complete this Microsoft Excel based on the value given here. But most of the time, degree of freedom, we have to remember the formula. Okay, so you are given total here. Total is a capital N minus 1. So degree of freedom of the treatment here between group, it is a capital N minus K, if I'm not mistaken. Again, sorry, K minus 1. So K minus 1, it will be 3 here. Okay, so once you get 3 here, then you can do 19 minus 3, then you get here. Okay, which is 16. So 16 here we get from capital N minus K. So capital N, what is capital N? 19 here plus 1, because to get total, capital N minus 1. So 20 minus 4, you will get 16 here lah. Okay, so when you get the degree of freedom, you can find the SS error here, the MS multiply with the degree of freedom, you will get the SS error here. Okay, you have the degree of freedom here, so mean square of the treatment, it is a SS treatment divided by degree of freedom. To get the F test here, mean square of the treatment divided by mean square error. So you have to know how to read the output. You have to know how to play around with the value in the output lah. Because sometimes like this question, there is no raw data given. So obviously, you cannot calculate from the data. Okay, you have to play around with this output. And also you only have 4 marks. So 1 mark for each value. Okay, so obviously it is not calculate from the data lah. Okay, if you calculate from the data, it will be like our quiz. Okay, you will have more than 4 marks lah. Okay. Okay, I don't think that we have to discuss the hypothesis here. Okay. Okay, we go to the two-way ANOVA. Okay. Okay, two-way ANOVA. Okay, so two-way ANOVA, actually we focus on the output. We focus more on the output. Okay, we are not expect a student to calculate from the scratch lah for the two-way ANOVA, because you know that if you calculate from the scratch for the two-way ANOVA, it will be a lot of time consumed lah. Okay, so two-way ANOVA, obviously you have to know how to read the output lah. Okay, for the two-way ANOVA. Okay, so you have to know what is sample here, column, interaction, bidding. Okay, so sample is a factor A, column is a factor B, and then you have interaction factor here, and then you have the error. Okay, and the rest it is similar. Okay, sometimes you will have incomplete table for the two-way ANOVA. So similar as a one-way ANOVA lah, you have to play around with the value here. Okay, sometimes we treat you by we give you the raw data, okay, and also the ANOVA. So if you calculate from the scratch, you just waste your time lah. Okay, if you have the output, use the output. Straight go to the output. Okay, you can use the F test here or the P value here, but depends on the question. Okay, so since there is no interaction effect exists between the amount of glass content and the glass particle size, so means that no need to test for the interaction. Dia dah cakap kat sini, there is no interaction effect. So you just put trust on this question, no interaction effect. No need to check, no need to retest. Okay, test the effect of glass particle size on the strength of the brick at 1% significant level. Okay, so how do we decide the glass particle size ni? factor A ke factor B? Okay. So kita tengok kat sini. Show all the effect involved between the amount of the glass content and also the glass particle size on the strength of the brick. Okay. So strength of the brick, it is your dependent variable lah. Okay, dependent variable. So independent variable, your two factors, factor A and factor B. So which factor mentioned first here? It is your factor A, and mentioned second, it is your factor B. So glass content, factor A, particle size, factor B. So what we need to test here, the effect of the factor B, which is a column effect. So we use this value. We use this information for this question. Okay, because we need to test for the column effect because particle size is a factor B. So factor B is a column factor. So we have to test for the column effect. Okay. So in this question, we didn't mention what method that you have to use, whether p-value or traditional one. Traditional means that you have to lah. Okay, so it's up to you. You can use the p-value method or you can use the f-test. Both will be accepted lah. Okay, try not to, both will be accepted. Try to choose either one lah. Do not write both. Okay, but usually if you have the output, I think it is easy to use the p-value approach. Okay, it is easy to use a p-value approach because when we do the decision based on p-value, whenever your p-value less than alpha, then reject H0. No need to think whether you have right tail, left tail, two tail, and so on. Okay, whenever p-value less than alpha, then reject H0. Whenever p-value greater than alpha, then do not reject. Okay, so it is simple to use a p-value, but it's up to you. If the question didn't mention any methods here, then it's up to you. You can use a p-value or you can use the f-test here. Okay, both will be accepted lah. Okay. Okay, so the question 4, it is about simple linear regression. Okay, chapter 5, identify the control variable, that's your dependent variable. Test whether there is a significant relationship between the number of books. So by using t-test approach. Okay, so already mentioned here, so you have to use the t-test. Okay, if you go through the module, okay, in order to test the linearity, you have 3 different methods that you can use. Okay, the first one t-test, the second one p-value approach, and the second one is a p-value, and the third one is a Anova. Okay, when we use Anova, automatically it's a f-test lah. Okay, so but here we already state that we need you to use a t-test, so you have to use a t-test. Okay, and usually for the case of simple linear, we try to save time. We try to save your time during the final exam. So most of the value already given. Okay, most of the value already given because if you do from the scratch the t-test here, it will be it will take much time lah. Okay, for the t-test. Okay, if you already go through the t-test, it will be quite complicated formula. You have to find the beta one and so on. Okay, so when you have the value, just use those value. No need to recalculate. Okay, kalau value kat sini salah pun kita akan bagi je you betul nanti sebab salah daripada kita. So no need to worry. Okay, jangan try to recalculate. Okay, don't try to recalculate the value given here because if you get different, you will be panicked, not us. Okay, if you get different value from here, you will be panicked. Okay, so if you have any value given in your question, just use as it is. Okay, jangan recalculate. Okay, use as it is. Kalau value tu salah pun, kita yang akan, kita akan betulkan nanti and follow lah. Kita bagi je you betul sebab value salah from us kan, macam tu. Okay, sebab my experience, some of student dia akan recalculate balik. So bila recalculate balik, sometimes they got different. Bila they got different, they use what they got. That's the problem. Okay, they use what they got, then they will get different lah. That's the problem. Okay, obviously we will deduct your mark. Okay, because already give you the value, no need to recalculate. Okay, you just waste your time and you will lose some mark. Okay. Okay. What else? Okay, so this is a multiple linear regression. Okay, so as you know, multiple linear regression, there's nothing that we calculate manually. Everything we read from the output. So obviously, it will be output in that question lah. Okay, so you have to know how to read the output. Okay, for the regression. Okay, coefficient of determination value. Okay, before this, some of student, so just a reminder for you, some of student they know notation, but they don't know the terms. Coefficient of determination value, it is R square. They know R square, but they don't know the coefficient of determination value. Okay, similar thing. You have to know the notation and you have to know the terms that we use. Okay, so interpret. So tulis dulu dia punya value. So multiple linear coefficient of determination, this value lah, adjusted R square, and then we discuss the probability in Y that can be predicted by series of X. Okay. So this is hypothesis for the multiple linear. We try to determine whether the predictor variable is related to the response variable. So similar to here. Okay. This hypothesis based on the Anova here. So it's up to you. Okay, we didn't mention any method here. So you can use the F test here or you can use the P value here. Both will be accepted. Okay, so E negative 10, everybody should know lah what does it mean. Okay, it means that you have about 9 0 before the 4. Okay, jangan you delete yang ni ambil depan je. Memang salah lah jawapan you nanti. Okay, E negative 10 means that you have about 9 0 before the 4. Okay, so kecil lah, almost 0. Okay, so based on the P value in the coefficient table, identify the significant predictor. Okay, P value in the coefficient table, we try to identify significant predictor. So coefficient table, the last table here, we refer to the last table here. Okay, so we try to decide on the predictor variable, significant predictor. So intercept bukan predictor, so do not consider this one. We just consider the 3 here. So what we do, so predictor will be significant if you have significant P value. So how the P value will be significant? If P value less than alpha. Okay, so you compare the P value here with the alpha. Okay, alpha is not mentioned here, so we use a 5% standard one. So compare with the 5%. Okay, so this one greater than alpha, so age not significant. This one also greater than alpha, then blood pressure not significant. And smoker here less than alpha, so smoker, factor smoker significant lah. Okay. 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 So you are given summary. This is the last subtopic for the chapter 5. Model selection. Okay, in this question, in this version of final, we give you a complete summary. Sometimes we give you output and then you summarize from the output, make this table from the output given. Okay, summarize on the information from the output given. Okay, Because in order to do the model selection, you need to have this table for some summarization of the information. Okay. So how to know how many model that we have? It is a 2 power k minus 1. So we have three predictor here. K is a number of predictor. We have 3 predictors, so 2 the power of 3 minus 1. That's why you have 7 model together. Okay, so these 7 models, it is a combination of the independent variable. Okay, so you have 7 model. 7 models means that you will have 7 different output. Okay, this information, it is not from similar output. Okay, dia datang daripada different output. So 7 row, 7 model here means that you will have 7 output. Okay, ingat bear in mind kalau you ada soalan, you are given output, make sure that you have enough output lah. Make sure that you extract the information from different output, not similar output. Okay. So the p-value here, it is an overall p-value. So overall p-value coming from significant f. This one, not from here. Significant f for each output. Okay, this is overall p-value, r square, adjusted r square, and regression model from here, coefficient. Okay, from this again. Okay, so we need to select the best regression model for predict the risk of having stroke. Okay, so it didn't mention, okay, 1% significant level. Okay. So significant model is a model with the significant p-value and also larger coefficient of determination, the largest coefficient of determination. Okay, so the first start, we compare the single predictor first. Okay, these three by looking at p-value and also r square, because r coefficient of determination for the simple linear is r square. Okay. Tengok dulu p-value yang significant. So 0.01, your p-value here must be less than 1. So x1 less than 0.01, x3 less than 0.01, x2 more than 0.01. So dah boleh potong x2 ni. Okay. Kita dah tak consider x2. Okay, bila kita tak consider x2 kat sini, the rest of the model with the x2 tak boleh consider. Okay, sebab S2 ni kita panggil bad model lah. Okay, so the rest of the model with S2 no need to consider. Okay, because p-value is not significant. So you boleh delete S2 here, S1, S2, S2, S3, S1, S2, S3. Dah tak payah consider, dah tak payah tengok. Okay, between S1, S3, yang mana yang the best one? Both p-value significant. And then R square, the largest one, S3. So S3 is the best model for one predictor. Okay, and then kita pergi pada two predictor. Oh sorry, S1, S2 pun dah potong, S2, S3 pun dah potong, automatically the best model for the two predictor, S1, S3. Okay. Yang ini pun dah potong. Okay, yang mana the best one, within the best. So you compare S3 here with the S1, S3. Both p-value significant. Okay, and then we try to compare the R square and adjusted R square. Kenapa yang ni pakai adjusted R square? Because it is multiple linear. Okay, multiple model. So ini compare dengan ini. So ini yang paling tinggi. So S3 the best one. Okay, S3 the best model. Okay. So the next question here, you dapat S3 the best model. So untuk buat this prediction, you pakai this model sahaja. Jangan pakai this model because the best one is this one. Okay, by using this value lah. So kita nak S3, S3 is a smoke, number of smoke. So here lah 20. Substitute S3 with the 20, then you get that one. Okay. So use the model that you get above the bus model. Okay. Kena tekak lah saya pun. Orang lain tak ada tanya soalan ke? Okay, ada yang tanya soalan. Untuk test apa tu? Untuk test apa tu macam mana nak tahu pakai B1 ke B0, beta 1 ke beta 0? Sebab linearity task, it is not beta 0. Linearity task, we test for the slope. You are talking about the chapter 5 lah kot beta 1 and beta 0. Okay. Untuk linearity task, we are testing for the slope of the regression line. So slope is a beta 1, it is not beta 0. Okay. And kita dah tak ajar beta 0. If you notice, dah tak ada test for the beta 0 for our syllabus lah. But if you go through the final exam, maybe ada lagi final exam yang lama-lama tu ada lagi test yang melibatkan beta 0 lah. Okay, beta 0 adalah test untuk intercept. Kita just nak tahu whether regression line passing through the origin or not. That's why we test for the beta 0. But for the linearity, we are testing for the slope. That's why beta 1. That one must be clear. That's why beta 1. Okay. Okay. Okay, so chapter 6, question 6 here. It is about goodness of fictans. Okay, I don't think that we have to discuss this one. It is clear that we have to use a goodness of fictans. Okay, question 7 here, it is a contingency table. Okay, so as I discussed, okay, because I'm the one who are responsible for the notes for the chapter 6. Okay. So for the contingency table, doesn't matter that you have independent test or homogeneity test. Step 2, 3, 4 similar lah. The difference is your hypothesis and also conclusion. Okay, step 2, 3, 4 similar. Okay. Variable under study, it could be failure mode or configuration here or what or number of failure. All will be accepted. Okay. Okay, for the goodness of it task, if the question will be from fitting of the distribution. Okay, yeah, the normal, yeah, the Poisson, and also another one is a binomial. Okay, so before this, kita memang ask student to calculate all the probability lah. Okay, but since the last 2 semester, I think, or maybe from last semester, okay, probability for the binomial or Poisson or normal will be given in the question. Okay, so kalau soalan you normal, kita dah bagi siap-siap probability untuk normal, no need to calculate lah. Kalau soalan you Poisson, kita dah bagi siap-siap probability untuk Poisson. Kalau binomial pun sama. So you already have the probability, you start from the expected frequency. Okay, for the goodness of it. I think that's all good for this version. End of paper. Any question? So the pattern of your this coming final will be quite similar. I mean how we arrange the question similar. Okay. Dia macam ni, chapter 7 tu, chapter 7 pula. Question 7, 6 and 7 confirm it is from chapter 6. So jangan pula tiba-tiba you buat hypothesis from chapter 3, jangan pula bikin confidence interval, macam tu. So sepatutnya you dah tahu pattern. At least kalau you tak tahu nak buat apa pun you tahu, ini something from chapter 6 nak kena pakai, macam tu lah. Okay, tak boleh. I hope that you takkan macam I don't have an idea what to do now. Okay, I hope that you tak macam tu. Okay, so when you go to the last 2 chapter, the last 2 question, question 6 and 7, so you dah tahu dah, okay, this question from chapter 6 means that I have to use something from chapter 6. Okay, like that. Okay, you tak boleh macam, okay, nak pakai yang chapter mana, tak boleh macam tu. Sebab kita tak akan, susunan soalan dia macam tu je. Tak adanya kita nak letak chapter 2, 3 tu kat belakang, tak ada. Okay, So at least you tahulah those pattern tu macam tu. Tak bolehlah pergi final dengan tak ada tak yelah dengan tak study, dengan tak ada idea. Okay. And another thing, kenapa you kena try all the final exam, okay, you try to train yourself to solve within 3 hours. Okay, try, okay, the first time buat tu boleh lah nak balik-balik modul ke more than 3 hours ke macam tu. The second time, train yourself not to look at to the module. Okay, try to train yourself for the 3 hours to solve. Okay, sebab you know final we have 3 hours, so make sure that you boleh buat, you siap. Okay, you boleh siapkan all those question lah. Okay. Some student dia akan pergi pada question yang melibatkan chapter 4, 5 and 6 dulu, tak ada masalah. You boleh dulu buat soalan daripada chapter 4, 5 and 6 and then go back to the soalan chapter 2 and 3 lah. Okay. Okay, chapter 2 and 3 dia bukan tak boleh buat tapi quite complicated the question You pun tahulah the chapter tu macam mana, macam tu. Okay, so kalau you are comfortable with the chapter 4, 5 and 6, so solve all those questions first so that you will not wasting your time lah. Okay, you jangan macam duduk termenung fikir macam mana buat, jangan. Okay, you memang kena move, tak boleh move macam tu. Okay, jangan ni lah. Okay, make sure to train yourself to solve within 3 hours. And also for the formula, okay, you will be given statistical table lah from BPA. You cannot bring your own. Okay, the statistical table will be provided by BPA lah. So BPA dia still ada version yang lama. So but most akan dapat version yang baru lah. Okay, but still ada yang silver one, that one lah. Okay, but the general formula is there lah. Okay, don't worry about that. Any more question before we end? Okay, previous semester yang dalam kalam rasanya dah ada answer scheme kan sekali. Ataupun you boleh sebab kita nak share soalan dengan yang sebelum tu lagi. Okay, macam untuk kita share jawapan dengan student, dia ada macam apa nak cakap kena buat something lah on that answer scheme. So you buat je dulu. Kalau you start dekat any question, you can WhatsApp me lah, you can PM me lah, and I will look at for you. Any more question? Okay, I do hope that you are ready for the final because you have a lot of time to study. Okay. Tak ada so stay safe, stay healthy. Hope to see you on this Monday. I will be the invigilator. Okay, maybe saya tak cam lah kot, dah lama sangat tak jumpa. Okay, so that's all for today. Good luck for the final. Anything you can always PM me lah. Okay, kalau malam tu sikit, lambat lah sikit saya jawabnya, mungkin pagi tu baru jawab. Okay, but you can always PM me if you have any questions. Okay, so that's all. Good luck for your final. Thank you, class. I will share the recording of our class later. Thank you.
Safi! Ringan. Safi! Safi! Tak ada berbual lagi. Siapa lagi? Tu paper. Safi! Dia ni tidur ni. Safi! Alah bongok ni.